Okay, we're talking about sequences again. And this recursive notation is kind of weird, but it's a way of writing the steps that you use to create these sequences. All right, so this one, it's going down each time. How much is it going down each time? Negative 4.2. That is called the common difference. So everybody write that down on your notes. It's going down 4.2 each time. Some people had a little trouble with this, going down to this, and saying it was 4.2. Think of it as temperature. We're in Minnesota. We're used to temperatures going into the negatives. The temperature was 1.6, and then it dropped 4.2 degrees. Do you get it would be negative 2.6? Think of it this way. If you added this and this together, you're going to end up with like 6.8, which is kind of weird. Okay, so how do you get from here to here? Well, this and this. But if I simply subtract them, I won't, it won't work right. So if you take the negative 4.2 minus the 1.6, it won't work right. So you got to do it in the right order. Anyway, this one can mess with your head. But bottom line is it does go down 4.2 each time. All right. If you haven't already, write me the formula for this. I'll remind you, start with use of 1. I'm going to teach you today how to start starting with something else besides use of 1. But use of 1's your first term for now. And the first term is what? 10. And then use of n is equal to, what's the rest of it? un minus 1, very good. And then it's minus 4. All right, and then there's one more thing. To make it a complete formula, you need something called the domain. N has to be greater than or equal to 2. It's always one bigger, whatever that was. And that's important because now today we're going to start using different things to start with. We won't always start with use of 1. All right, now what is the 11th term? It'd be really handy if this was in the calculator to get the 11th term. So I want to remind you how this one, where it starts at 10 and it drops 4.2 each time, how we would do that on the calculator. All right, so get your calculator up. And now, when you're in your calculator, go to the y equals screen, and if it looks like this, you're in the right mode. If it looks like your old-fashioned y equals, then you have to go under mode and change it into sequence mode. Down here and over here. That's sequence mode. Okay. So anyway, getting back into the y equals screen. This top number, up until now, we've always started with a 1. And on this problem, we are going to use 1 as our first thing. Use of 1 is our first term. So often people think that's the starting value. Like, see, there's a difference here. Use of 1 is 10. So which goes in that top blank, the 1 or the 10? The 1 does. The 10, the actual number that you're going to start with is 10. That goes on the third line here. So where mine says 2000, I got to change it to 10. And then up in here, hopefully you still have the un minus 1 there from last time. And we change that. After that, we change it to minus 4.2. Minus 4.2. And there's one, I still have one more number in there. If I hit the DEL or delete key, that makes it. There we go. I think it's all right. Now, how do I check if I did it right? Go over to the table. Now, I happen to be playing with my table settings before, and I was at 65 for a starting point. So I'm changing my table settings to start at 1. Notice that was above the window key. See where I did that? It's under right there. Right, I just left it red. Right above the window key. All right, table settings 1, and then I'm going to go to table. Second graph gives me table, and there we go. There's your first 5, 6, 7 terms. Okay, so what if we wanted term number 20? Oh, what do they want? 11? Term 11? Okay, I just can arrow down to term 11. That's easy. Because it's so close, I might as well just hit arrow down a few more times. Poof. But what if I said term number 117? Table settings, yes, you can use table settings. Or go back to your main screen, quit out, go U, right above the 7. Parentheses, 117. I want to see this on your calculator. Now I will know who's been really following me and who's been lost and hasn't been saying anything. I'm going to hit pause and come around and make sure yours is looking right. Okay, I'm recording again. I took a little break there to make sure kids were on. Hey! Thank you. Make sure kids were on track. All right, now, what are we doing next? We're going to change some of these numbers around. We're going to be going to multiply. That's called geometric. And so we're multiplying by something each time. But we're not going to multiply by 4.2. I want to make this a real world kind of problem. We're going to make our investment grow at 8%. Who knows what to multiply by to make something grow at 8%? Yes. If I multiply by 0.08, it'll actually shrink. You're close, though. Yes? Yes. 1.08. Okay, everybody change it to a multiply by 1.08. That's going to grow 8%. Now, $10, that'll never really amount to anything. But let's say you start with $2,000. Okay, your great aunt Tilly gives you $2,000 when she passes away. And now you got $2,000 in the bank. And it's going to grow at 8%. Now here's something though to stretch your mind a little bit. Let's go look at the table for a minute. Go to second table and arrow up until you get to the 1. If yours is like way off from 1, if it's like your table is in like the hundreds or something, go to table settings, which is right above window. Everybody please get here, and I'm going to pause and make sure you are there. If you're not, ask the kid near you, please. I can't be the only one doing this. There are kids near you that know how to do this just as well as I do. Okay, now we can talk about this a little bit. When we do it like this, it says 1 is 2,000. That's sort of like year 1 is 2,000. Year 2 has grown. Why? Because we invested it in something and got 8%. That would be like putting it in stocks. The average in stocks over the last like 50 years is about 8%. Okay? So it grows, not super fast, but on average grows like 8%. Well, if you look at 1 and 2, it really doesn't make sense because it looks like it takes 2 years to get to 2,160, and it really only takes 1 year. So it would really make more sense if we started with a 0 instead of a 1. Like 0 should be 2,000. Like year 0, when you first get the money, is like year 0. Then after year 1, you'll have 2,160. So let's change that. Go to the y equals. Where do we change it so we start with 0 instead of 1? The very top part. The 1 there. Make that a 0. And then go back to your table. Now do you see that in 0, I start with $2,000, and after 1 year, I have 2,160? Doesn't it make more sense now? After 1 year, I have 2,000. It's not after 2 years. It's after 1 year, I have 2,160. But what would even be cooler is if we started with something like your age. Would you say most kids in here are around 14 years old? Raise your hand if you're 14. Raise your hand if you're 15. It's about half and half. It's really close. In fact, I want to count that one. 14-year-olds, raise your hand again. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Holy cow. Now 15-year-olds. You got to see if it's exact split. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my gosh. All right. That is like, that's freaky. There's 15 14-year-olds and 14 15-year-olds. Yes. Smartboard's 939. Oh, so close. All right. Thank you for warning me, though. So I'm going to have to go take attendance now. All right. Sorry about the distraction there. So now, what I was going through with you is if we change this to a 0, now we will see better that after 1 year, it has grown to 2,160. After 2 years, it's grown to 2,300. And I was saying, what if we did it based on your age? Let me show you how this would be cool. Go back to the y equals. Change the top number to be, let's make it 14 because there's more 14-year-olds. Go with 14. And just keep all together. You can always change it later, but for right now, make it a 14. Then go back to the table. And now, isn't it kind of annoying that it says error, error, error because I'm not at the 14th spot? Now, you can simply arrow down, but it's actually faster to go to second table settings, tell it to start on 14. Oops, unless you type wrong. 14, and then go back to the table. And it'll start on the 14th spot. So can you see now that age 14, you have $2,000? At age 15, you have 2160. At age 20, you will have $3,000. So your money has grown pretty well. It's gone from 2,000 to 3,000. At age, well, let's go to like age 65. Tell me 2 ways I could do that. Okay, 3 ways. I could go out here and do U of 65. Another way, arrow down a gazillion times. That'd be kind of dumb though. Table settings, go to 65, go back to your table, poof. It'll be there. Now, not Abraham Lincoln, it was Benjamin Franklin had this idea, and he saw something like this, and he thought outside the box. Instead of just waiting 65 years and having it grow a fair amount, he left his money to the city of Philadelphia, and he said, oh, but by the way, you can't touch it for 100 years, because he wanted it to grow a lot, and he knew the power of compounding. So he said, I'm going to leave you this money, but you can't touch it for 100 years. All right, so let's do that. Let's go out to 100 years. Well, if you start at age 14, which we have right now, we'd have to go to 114, right? So let's do the 114th spot. I'm going to do it through table settings. Don't talk now, please. 1, 4, and then I go to table settings. That $2,000 would have grown to, boy, this thing's taking a long time to calculate. Is there a faster way? Oh, yes, there is. Now, the faster way I'll show you in just a second. And look at this on the table. It's also restricted to only a few digits, and it's got to do this E6 thing. That means move the decimal over 6 spots. Okay, so it's a pretty big number. But let's go out of here, second quit, and let's show you how we could have done that easier. U is right above the 7, parentheses, 114. Enter. And it'll be way quicker. Boom, there it is. Your $2,000 has grown to $4 million. Think about that for a second. It doesn't always work out that well because the stock market doesn't always average 8%, but it has averaged 8%. If it just keeps averaging 8%, that doesn't mean every year. Remember, averages are good times and bad times all averaged together. And do you think that Ben Franklin left them only $2,000? Ben Franklin was a pretty famous, wealthy guy in our country. Let's say that he had left $1 million. I'd like you to go to Y equals, and I'd like you to go down here and change this 2,000 to 1 million. And let's see now at the U114. Again, that's assuming a 14-year-old was given the money right now and had to wait 100 years to cash it in. Some of you might live to 114. It is very possible. Not many of you will, but right now we have people living to age 120. Not everybody, but there are people. And the point is that we're getting more and more medical advances. Some of you guys will probably live to 114. It'll probably be a girl, by the way, because usually girls outlive guys pretty strongly. All right, and again, I did this table thing, and now I can't read it because it's got E9 in it. I got to move the decimal over 9 spots. I might as well just go out of here and do it this way. Parentheses 114. So if you left $1 million, let's try to move the decimal over in our head, or commas over in our head here. That would be $2 billion. So all of a sudden your 1 million has grown to 2 billion, which is pretty impressive. All right. So that's just some fun with numbers, and now let's talk about some problems that you will actually have to handle in the real world. Go back to your Y equals screen. Almost every problem is going to start with 0 or a 1. U sub 0 or U sub 1. So go up here and let's make it a 1, because that's what most problems are going to be like. Now we just talked about growing by 8%. That was multiplying by 1.08. Let's talk about shrinking by 8%. What would I put in right here? No, thank you for trying. If I just put 0.08, that's going to make it 8% of what it was. If something's 8% off sale, you don't pay 8%. What percent do you pay if it's an 8% off sale? Yes. Yes. So everybody right here put 0.92. And be careful, because if there's still any leftover junk there, like the 8, you got to hit the DEL key to get rid of it. So it's just 0.92. Okay? That's like an 8% off sale. Do that right now on your calculator. And we're going to not have $1 million because it's not likely the item is going to start off at $1 million. Let's say something's decreasing 8% in value every year. That's a lot like a car. The average car nowadays costs about $25,000. So we're going to go with $25,000. I'm going to say this is like you bought a car for $25,000 and it goes down 9.2%, sorry, 8% per year, which would be 0.92 factor. Then, if I go now to my table, I wonder where my table settings were at. It's probably around like 2,000 or whatever. Oh, 114. My table settings better go back to like 1. That's where I would start with here. Now I'm going to go to my table. Okay, there we go. See how in year 1 I have a $25,000 car? In year 2, what's my car worth? $23,000. You get how it goes down in value? This happens in the real world. Cars do not go up in value, they go down. You buy a brand new one at $25,000 and 7 years later it's worth $15,000. That's really pretty accurate because it's going to have gone down about 10 grand. Yes. Yes, if you have a really old car, if it gets really old, all of a sudden the price might start actually going up again because it's a collector. It depends on the car. Some cars were really popular and therefore they're worth a lot now. If they're really rare, that's another reason they're worth a lot. The Batmobile, there's only one of them built. It wasn't that expensive to build. They took a concept car that was kind of a cool looking concept car and they added a few features to it and that became the Batmobile. Sold like for $4.2 million the other day. Okay, because there was only one of them. So anytime there's only one of something, it becomes really, really valuable. Okay, so I would like you to tell me, here's a more realistic situation for you, because I doubt any of you are buying a car real soon. Let's say that you are at the store, and do you know how at like Macy's or at any major department store, they mark things down? If they haven't sold them for a while, then they like start, okay, let's go down 20%. And if they still are, if they're on the clearance rack, they're like, now it's an additional 20% off. And some stores' policy is every week it doesn't sell, they just mark it down another 20%, another 20%, another 20%. So at some point, you can get some shirt that might have like a weird looking pattern on it or whatever. Some people don't buy it for some reason. That'll be down to like 90% off. Like you can get it for 10% of the original cost. They just keep going down, down, down. Eventually, if it goes low enough, they actually just give it away. Not to people at the store though. They give it away to like charity. Say, okay, take all the ones that haven't sold now, give them to charity. Okay, let's take that scenario, go back to your Y equals screen, and say that it's a $80 shirt, and you really like it, and it goes to clearance, and it's going to go down 10% per week. At what point would it finally get down to 30 bucks? I'm going to say that again. You have a shirt that is $80 originally. Right away, where am I going to put that $80? Line 1, 2, or 3? Line 3. Okay, I'm going to put that 80 bucks right here. Next, I have U sub n, U sub n minus 1. I can leave that all in there. And is this 0.92 thing still accurate? No. 0.9. 0.90. I can put a 0 there. All right. And now, if I go out to my table, the $80 shirt next week, if you want to say week 2, it's at $72. Week 3, it's at 64, 58, 52. I said, when will it get to 30 bucks? Well, I just keep arrowing down, and I see when does it get to 30 bucks. Week what? Week 10, it's finally 30 bucks. It's actually 31 bucks, but close. All right, so 10 weeks later, so you're going to have to wait about a couple of months, a little 2.5 months. It's possible. It's possible. Maybe it's just kind of pattern that you like but not any other people would like. Maybe it's a size. Maybe you're like a size super small and not many people are that size, and so the shirt might stay there for that reason. I've seen like triple X's there before. There's like not many customers come in looking for the Giganto shirt. So, all right. All right, anyway, that's a real world problem that you're going to have to do on your math for tonight. One of the things that I also want to make sure I cover with you, this happens a fair amount. Let's go through the slides. There's something called the common ratio, and you need to be able to find that easily. Look at this slide right here. Get to the one that starts with 5, 7.5, 11.25, etc. And on this one, are they adding the same thing each time? No. So therefore it must be geometric. They must be multiplying by something. So how do you figure out what they're multiplying by? It's easy. You take this one, you divide it by this one. Okay? This divided by that. It has to be in that order or it won't work. So grab your calculator, take 7.5 divided by 5. You get 1.5? All right. So what does that say? It's going up what? Times 1.5 means going up what percent? Times by 1.5 is the geometric, and therefore it's not a common difference, it's a common ratio. Because you get when you divide these things, you're making a ratio. All right. Look at the next one. How would I get this? What is this going up each time? You take this one, divided by this one. It's got to be in that order. Divide those two, and what kind is that? Arithmetic or geometric? Geometric, because it's multiplying by something. And what are you multiplying by? The common ratio. And what is the common ratio? 8.5. Oh, 3.5. That makes more sense. Good. All right. So then if I was going to put this in my calculator, I would have a starting term of 2.35, and then I'd have a multiply by 3.5 each time. So I go back to here. I can start with 0 or 1 for my first term. We talked about that. I would recommend generally you're starting with 1 unless you're talking about a real world situation like money, time, things like that. It's best to start with 0. All right. And then the starting amount was 2. What was it? 2 point what? 2.25. And then the amount I multiplied by was what? 3.5. There we go. That's how you put it in the calculator. Remember, the first line is u sub what do you want to start with? U sub 1 is what I'm going to start with. The bottom line is what's the first term, and then this is the whole, like, take the next term and multiply it by what, or add what. Yes? Arithmetic means you add something each time. Okay, let me look at that sequence. Let's see if you're right. Is this one where you add 5 each time? Oh, maybe you do. I thought this was the kind where you multiply each time. Thank you. You make a good point. Sorry. You can always look at one and assume it was a multiply, because you could multiply by something to get up to that number. But you're right. This one's an add what each time? 5.9. If you add 5.9 each time, you get the answer. That's totally different. Sorry about that. I did not do this example last hour, so it caught me off guard. It's just an adding one. So that's arithmetic, and therefore it's not a common ratio. It's called a difference. You can subtract to get it. It's called a difference. All right, so this would be arithmetic and a common difference. So on that one, I would have to add 5.9 each time. Sorry, go back to here. Go to add 5. Plus 5 point. All right. Should I get that right now? Yes, I do. Okay. So your homework felt a little long for me today, and so I have found a couple that I can have you skip. Everybody go look at your homework with me for a second. It is under Schoology, and I'll tell you which problems you can skip. But I want to get the first one done with you here before I stop the video. So everybody right now, get into Schoology. I'm going to pause for a second while I get there. Okay, so here is that first worksheet. This one's really easy. It tells you it starts with 32, and then you multiply by 1.5 each time. Okay, so you wouldn't even have to have used a calculator with the sequence mode and everything. You just take 32 and go times 1.5, get the answer. Times 1.5, get the answer. But if you want to put it in sequence mode, I just showed you how to do that. You should be good at that by now. Notice they have a 0 here. So your first line of the calculator, you put a 0. The second line of your calculator is always the use of n minus 1 thing. And this is times 1.5. And the third line of your calculator is always, what is your starting term? 32. That's this number. Third line is always that. Okay, so that's how you get that in your calculator. The ones I'm going to let you skip for today are problems. Make sure I stay right here. I'm going to have you skip problems 5 and 6. That'll keep you from having to type those into your calculator. Maybe this is extra practice you really don't need. All right, last one I want to help you with is number 9. Everybody look at number 9 with me, please. Because once you get a little help starting on number 9, it should be a piece of cake. Problem number 9 of your homework. Got your homework up yet or not? Apparently you didn't get your homework up. I know what you've been doing, but you haven't been doing what you're supposed to be doing. All right, thank you. Would you read me number 9, the directions part, top part? In the week of February 14, all right, so they start at $80. So do you know what you're going to type into your calculator here? First line is, I told you whenever it's a real world problem, best to start with what, 0 or 1? 0. So the first line of your calculator, you're going to put in a 0. The next line of your calculator is always the u sub n minus 1, and then it's whatever it happens each time. If they're going down 25% each week, you're going to use what? Times by 0.75. If it's going down 25%, you do not put the 25% here. You put 1 minus the 25%, which would be 75%. And then the third line, which is what I haven't told the calculator yet, is what to start at. 80. I did go with those. What is the price during the 4th week? So once I get this in the calculator, it's going to be easy to find out what's the price in the 2nd week, and then what's the price during the 4th week. Once it's in the calculator, so it's good. All right, so I'm going to put in 0 for the first one, and then times by 0.75. So I'm going to get this up here, and go to 0 here. I'm telling you, anytime it's a real-world problem, instead of like, what's the 4th term? That's not real world. But if it's like, what's the 4th week? Then I would use a 0 to start with. Okay, that's how you do those. Have a great day.